Welcome everyone, my name is Yusuf and today we are diving into the world of NFTs. We will be taking a closer look at another sCrypt powerful SDK called sCrypt that demonstrates, inscribe and manage non-fungible tokens and even the fungible tokens like BSB20 version 1 and also BSB20 version 2. So if you are excited to learn more about NFTs and smart contract, you are in the right place. So if you are new to sCrypt, you need to install the sCrypt CLI into your machine by running npm install -g means global sCrypt -CLI. This will install the CLI into your machine globally. You need to create a new project. You will create the project by running npx sCrypt -CLI project, then the name of your project. So let's say the name of the project is demo. So if you run it, a project will be created. So I already have my own, so there is no need for me to be creating a new project. So you can change the directory into your project, for example cd demo. So you will be into your project directory and run npm install so that you get all the dependencies. So in this project demo, there is a directory called source directory, and inside the source directory there is another directory or folder called contracts, and inside that folder you will have your own smart contract files. So for this video we are going to use a file called ordinals because we are going to inscribe an NFT and also transfer the NFT by writing a smart contract that will put a constraint on how to transfer the NFT. So the smart contract will make sure that some certain conditions are met for the NFT to be transferred. So in this video we are going to use a smart contract, a sCrypt smart contract, and this smart contract we will log two numbers, and whoever provide the sum of that two numbers can easily transfer the NFT. So let's get going. So class of our smart contract, let's call the smart contract demo NFT. So I call it a demo NFT, and it will extend the ordinal NFT base class. So in a regular contract we used to extend the smart contract base class, but for ordinal NFTs we must extend the ordinal NFT base class. So we are going to have two properties since we are going to log two numbers, and the numbers should be added so that you can easily interact with the transfer the NFT. So let's call the first number x, and it is of type big integer, and also another property we call it for example y, and it should also be of type big integer. So we have our properties. Let's initialize them inside the constructor. So constructor, we have x big integer and also y which is of type big integer, then super. So after the super we are going to pass the argument in the init. So this dot init, then split arguments, and this dot x equals x, just like a regular smart contract, and this dot y, this dot y equals to y. So we are having an error here. So this is how we initialize properties inside the constructor. So, and after that we will have a method, and this method will allow someone to interact with our contract so that he'll provide the sum of that numbers, which is x and y. So the method should be public. So methods, and it will have a modifier public, and this public we are going to call the methods, let me call it unlock, and it will have z, which will be the sum of the numbers, and it doesn't have a return type. So we are going to make sure that the person interacting with the contract will provide that this dot x plus y must be equal to the number z he is providing. Otherwise it will result in an error which will say incorrect sum, because the sum of the contract is incorrect. So this is just a simple contract that will log two numbers, and whoever provides the sum of that numbers can interact with the contract. So this will be like a constraint on how the NFT will be transferred. So let's get going and inscribe our contract. Firstly, we are going to inscribe it with a text. So async function, and we are going to demo the NFT, but we are going to load the artifacts. So after the contract is compiled, there is an artifact folder here which will get the ordinal.json, which is our file there, contract. So, and after loading the artifact, so since we are going to inscribe a text, so let the text equal, let me call it hello sCrypt. So this will be the text, and let instance of the contract should be equal to new demo NFT, and we are going to pass the two numbers, the two properties that we will lock in the contract. So let me call it 2, and y should be 3, so that the sum will be pipe, right? So after that, I'm going to connect it with the signer, and in this case let me use default signer. So let me connect my instance with default signer. So get default signer, as you can see it here in the IntelliSense, default signer, and I connect my instance with a signer. So as you can see, after that we are going to inscribe it with a text, as I said earlier. So inscription, let me call it inscription transaction. Inscription transaction should be equal with instance dot inscribe text. So this inscribe text is a function that will take an argument of the text to be inscribed. So in this case, we have already have our text to be inscribed, which is hello sCrypt inside a text variable. So we'll just write text. So this will inscribe the text as an NFT. So let me write it to the console so that you will see how it the transaction ID. So console.log, so call it inscription transaction ID. Inscription transaction ID should be inscription transaction.id. So let's run it so that our NFT will be inscribed. So we see the inscription transactions. So let me run the file. So I'm running the file npxt is not, then this is my file path. So click OK. So I will get the inscription transaction ID. Yes, as you can see, this is the encryption transaction ID. So after getting the inscription ID, I can easily transfer the NFT to any address by giving the sum of that two numbers, since in the constraint of the smart contract that the person that will interact with the public method of the contract is the one that can provide the sum of the numbers. So you can put any constraint on how your NFT will be transferred as you like. So that's the case. So here, let me transfer it. So const the transaction is transfer transaction, and should be equal with instance that methods. My public method's name is unlock, and I'll provide z as an argument, so which should be the sum of that numbers, and 2 plus 3 is 5. So after that, I'm going to transfer it. Let me call transfer and transfer. So this transfer should be a new ordinal non-fungible token pay-to-pub key hash, and this should be OD NFT pay-to-pub key hash. So it's just a normal pay-to-public key hash for NFT. So you provide the address, should be an address. So let me see my address. So I'll use this table. So it should be 2 byte string, and should be 2 byte string. Yes. So I can easily transfer my NFT to this address. So let me write it to the console, the transaction ID if it is transferred. So console.log, say NFT transferred successfully. So with the transaction ID of transaction, transfer should be capital T, transfer transaction dot ID. So that's it. So let me save it and let me rerun it again. So let me run the contract. So in this case, our contract will be inscribed and also be transferred. Since I'm rerunning it again, yes. So as you can see, it has been inscribed and it has been transferred successfully. So next, let me show you how you will inscribe an image, since you have now inscribed a text successfully. So let's move on to see how are we going to inscribe an image as an NFT. So let's get going. So for the encryption, I already have my image here in the same folder with the contract. So this is the image, is another work. So let me show you how we do. So the only difference is that here in the text inscription, we using this Inscribe Text, and it only needs some small changes. So firstly, we don't need this, and also we are not going to be using this function anymore, Inscribe Text. So it should be image. So let me get the image file. So should be cons image, so image equals the file path. So I will read the read file sync. So you read the file, and also join the path and directory name. So it should be directory name and the image. So in this case, the name of our image is cell3.png. so this is the image file. Cell3 is a png file. So and should be to string which is base 64. So should be base 64. So we get the image here, and after that we are going to be using the inscription transaction. Should be instance.inscribe image. So as you can see the difference, in our previous text encryption we use Inscribe Text, but here since we are inscribing an image, should be inscribe image, and also should be the file path of the image, which is image, and also the content type. So should be content type from sCrypt or the also dot png. So as you can see here, so since our file is png, so that's the only thing you need to change. So I think what we have did is we comment the text inscription, and also get the image file paths, the image from the file, and also inscribe it as image, then the file path and the content type. So that's all you need. Then you save your file. So let me clear the terminal. Clear. So let me inscribe the image. So it's the same part. So we are going to inscribe the image now and transfer it also to that address. So it is running. Yeah, so as you can see, the image too has been inscribed. So if you want to learn more about sCrypt and NFTs, fungible tokens, and many more, and even the smart contract with sCrypt, I will leave a link in the description of this video. And don't forget to subscribe, like, and share this video for others to learn too. So thank you everyone.